Hello everyone, I hope this video find you in good health. My name is Boulou Mahamadi. I come from Burkina Faso. I am from BONI University in the laboratory of algebra, discrete mathematics and computer science. I work on security and optimization of energy consumption in wireless sensor network. For this paper, me and my collaborators have worked on follow topics: LEACH-S enhancement to ensure wireless sensor network stability. Throughout this presentation, the follow point will be clearly detailed, namely the context of the research. After that, we will discuss the problems we are addressing in this work, and we will refer to the different existing words. We will present our solution and estimate the performance of the solution, and at the end we will conclude this work and make an assessment of this work. Due to the miniaturization of sensor node and the easy and low cost of deployment, the use of wireless sensor network has grown rapidly. Several fields are concerned, include environmental monitoring, e-health, precision agriculture, and home automation. The sensor nodes have limited resources. The issue addressed in this paper is that routing and network topology rebuilding lead to considerable energy consumption in wireless sensor networks. We ask how to successfully reduce energy consumption in the process of building topology and routing in wireless sensor networks. For that, we have set the objective of studying the different energy optimization techniques in wireless sensor networks, particularly those based on clustering. How to reduce instability due to disjunct formation in terms of nodes in wireless sensor network clusters. To carry out this work, we study one of the clustering protocols, namely LEACH and its variants. LEACH uses random cluster rotation and evenly distribute the energy load across the network nodes. As insufficient, random cluster head selection does not take in account the amount of energy of residual energy of the node. Some authors have proposed LEACH-P, which idea is to add at each turn after the first CH selection according to LEACH. A second selection is introduced to modify the number of CH taking into account the residual energy of the node. The sum of this solution of LEACH-B is based on residual energy for cluster head selection. Also, as insufficient, LEACH-B does not take in account the distance, the position with the sink node. Also, some authors have proposed LEACH-S. In LEACH-S, from the second cycle onward, the cluster reconstruction cycle are suppressed, and the election of a new CH is done by comparing the residual energy of the CH with the average cluster energy. Strong here there is lack of cluster reconstruction, and as limited here in LEACH-S, we have the comparison of energy residual and energy average, which require additional processing for the node. And also we have uncontrolled clustering in LEACH-S. We retain these two issues in LEACH-S. Uncontrolled clustering in LEACH-S lead to instability in the network, and the change of cluster head is based on the calculation of the average of the remaining energies of the cluster. This leads to a rapid change of cluster head, resulting in instabilities. To resolve this issue in LEACH-S, we propose a new approach. Our solution is based on LEACH-S and work in two phases. In the first phase, we do the node membership process in cluster, and the solution, and in second phase, cluster head change process. If a node receives an announcement message from several CH, cluster head is calculated the cost associated with each cluster head using the fuzzy system. The fuzzy system takes as parameters the RSSI and the number of member nodes on the cluster head. The node will choose the cluster whose CH has the best cost. After that, they send a membership method to their cluster head. This method contains all its information. For cluster head change process, the cluster head function in our solution, the cluster head function is split in turn. Unlike LEACH-S, which average the cluster energy and compare them with its residual energy, in our new approach to solve the instability problem in cluster, we define a quantum of energy that the CH node must exhaust before give up its place to another node. To do this, the outgoing cluster head node informs the new cluster head of the list of nodes that have already been elected, and also list of nodes not yet elected. Choose the cluster head will choose a node from the list of not yet elected node as its successor and add its identity to the list of already elected nodes before handing over its roles. As estimation context, we consider two identical 17-node network in running with the LEACH-S protocol and the other with the BMN LEACH-S. We observe the process of these two networks at different communication around T0 to T16. We assume that during at communication around a member node consumes 0.3 5 energy units. To communicate with its CH, and the latter also use 0.5 unit energy for the process of each received message. Therefore, the process of message from end node and CH need. CH choose a replacement when it exhausts an amount of energy equal to C4 unity energy. In the experimental phase, the 17 nodes form 3 clusters, namely cluster I, cluster G, and cluster K. Each node has 20 unity energy as its initial energy. We have on the left a network running on LEACH-S, and on the right a network running on BONI LEACH-S. We notice that our solution balances the node between the different clusters during the construction of the topology, contrary to LEACH-S. From this experiment we have collected data, and from this data we have obtained the following result. The result of the experiment show that in all the network with the LEACH-S protocol we observe 28 instabilities against 24 for our solution. We can conclude the use of LEACH produce more instabilities than the use of BONI LEACH-S. If we analyze the result by cluster, the imbalances is more visible. The imbalance is more visible. In cluster I, we see that the cluster head was changed 16 times with LEACH-S versus 8 for BONI LEACH. Know that each cluster head change induces special control message broadcast for new cluster head announcement. We can deduce that BONI LEACH-S improve the routing load compared to LEACH-S. In conclusion, we have studied some variant of the LEACH protocol. We proposed a new variant of LEACH which named BONI LEACH-S, which allow balancing the net between the different clusters and describe an efficient method of cluster head selection. This reduces the numbers of instabilities and consequently reduce the energy consumption. In the future world, we plan to carry out exhaustive performance tests. Thank you for your attention. For more questions, send a mail to my email. Thank you.